Okay, power. We know from grade 11 that power is equal to work over time. But we know from this semester that work is connected to voltage. V is equal to W over Q. And so if we rearrange this for W, work is equal to Q times V. So let's sub that in to power, and we get power is equal to QV over delta T. But Q over delta T is just current. So power is equal to IV. Okay, so power is still equal to work over time, but we tend to use that when we're talking about mechanical work and mechanical power, but this one we use in electricity. Okay, so current times voltage. Easy way to remember it, if you're sick and not feeling great and really weak, they take you to the hospital, they hook you up to an IV, and you get more powerful. We know that power is measured in watts, and from last year, or grade 11, a watt is a joule per second. But what this one tells us is that a watt is also an amp times a volt. They're really the same thing, because we know that a volt is a joule per coulomb, and a coulomb second is an amp. So they really do work. Okay, so power is equal to IV. Now your textbook is really weird. They do a whole section of questions on this, and then they were like, oh, but V is equal to IR from Ohm's law. So if we take this and sub it into power, we get power is equal to I times IR, or power is equal to I squared R. And it's like, oh, look, it's a new equation. And then they do more questions on that. And then they are like, oh, but wait, I is equal to V over R. So we can sub this into our power equation, and we get power is equal to V over R times V, or power is equal to V squared over R. And they box this one and say, oh, look, we have a third equation. So we do. In reality, we have three equations for power. This one, power is equal to IV, should be easy to remember. And these two just come from subbing in Ohm's law. I don't know that I'd say memorize them. I'd say understand that you just rearrange for V or for I and sub it in. You get these two. Okay? So they're given here on your sheet. They're highlighted. But notice this little box right here on your note sheet. It says when I changes, V changes. And when V changes, I changes. But R always stays constant. Now that you might be like, huh? But let's suppose I said a question. I said current is 8 amps. And when the current is 8 amps, you get a power of 80 watts. Which means, of course, that means the voltage must be 10 volts. And then I might say, but what would happen if I double the current? What would happen to the power? So you might want to say, oh, if you double the current, the power would double. But that's not actually true, because if I double the current, the voltage will also double. And so it means not only does the current double, but so does the voltage, which means the power would be a multiple of 4. So if you run into a question where they're doubling the power, or the voltage, or the current, it's always safer to use one of the ones with the R's, because the R doesn't change. Otherwise, you'll have to go back and figure out what's the new voltage when they change the current, or what's the new current when they change the voltage, okay? Don't worry, there'll be some questions that'll get you on that one, and then we'll talk about it again more on Monday. All right, so we have power is equal to IV, power is equal to I squared R, or power is equal to V squared over R, but really all the same equation. Just another couple of seconds to talk about energy. Because when we use our electrical items at home, it's not just how much power they need to run, but it's also how long do we run them. So if we go back up to this equation where we had, not this one, power is equal to work over time, okay? Power is equal to work over time. We know that that work is really the change in energy, or the energy that's been used. So if we think about how much energy we are using when we run an electrical device, it's really then just power times time. And we don't often write the delta because it's the change in energy, but we always assume we start at 0. New Brunswick Power actually sells energy, not power. Because it's not like that your stove or your hair dryer takes however many watts to run. It takes that many watts and you run it for 3 hours or 2 minutes. Okay, so it's really how much energy are you using. So New Brunswick Power is poorly named. They don't sell power, they sell energy. Now we know the unit for energy is joule. And we know from this that a joule is equal to a watt times a second. But when we're talking about how much energy we use in our home, a watt second or a joule is a really tiny unit. And if your power bill was in watt seconds, it would be like 200 billion watt seconds. The number would be so huge that it would have no meaning in people's lives. So instead, they change it to kilowatt hours. Because a kilowatt hour is much larger unit. To go from a watt to a kilowatt, you would of course divide by 1,000. And to go from a second to an hour, you would divide by 3,600. So you will see on your power bill, if you happen to go look at the power bill for where you're living, it's written in kilowatt hours, okay? Because it's a better unit. So we have another equation here when you want to figure out how much energy you're using to dry your hair or to run your laptop. It's just the power that takes times time. Now, the power company is always asking about if they could put the rate up. So the rate is how much are they selling this power for. And the rate is usually in cents per kilowatt hours. And so we can get, what does it cost? What does it cost for me to charge my laptop? Well, the cost would be how much energy are you using times the rate that the company is selling. And I think in your notes I wrote it other way around, right? So if the rate is 5.2 cents per kilowatt hour and it takes you 10 minutes to blow dry your hair, then you can find out how much did it cost you to do this. Okay? So we have cost equation, energy equation, and your power equations. So on this sheet, at the bottom where it says homework, you will see there are 4 pages of questions. I know it looks like a lot, but they're pretty pathetic, and they're with these equations. They should each take you about a minute each. Okay, so please try them because we only have 5 days left in the semester. I'd like 2 of those to be review and 1 to be a test. Means we have 2 days left to finish the unit. So Monday I'll go over these questions. I'll go over number 4 and number 5 in the complex circuit. We'll finish the last of the new stuff. We'll do some more complex circuits. And we'll talk about, do you want your test on Wednesday or Thursday? And whichever day you have it, then the other one and Friday will be the 2 review days. Okay? So thanks for working on this stuff. We'll see you Monday.